Alright, so we've been looking at exponentials and logarithms. Remember that we've looked at our graphs for both of them now. We've looked at how to convert between the two now. And we've looked at some basic equations at this point. Do we remember what property we used for some of our equations? Yes, no, maybe. So it's when my bases were the same, we were allowed to use the not quite. Those were our log properties, which we have been talking about those, but this was before that, when we had some basic exponential and basic logarithmic. In order to solve them, if I had stuff that had the same bases, we could use what property? The one-to-one property. And that still applies. So if we can use our one-to-one property, we want to. So remember that our one-to-one property tells us that if we have things that have the same base, then our exponents must equal each other. Or if it's a logarithm, then whatever's inside of the logarithm must equal each other. Now remind me, what does IFF stand for? Does anybody remember from geometry? So it stands for if and only if. So we're saying b to the x equals b to the y if and only if x equals y. So those two things have to be true at the same time. Same thing with our logarithmic statement. Now, the thing is, or what we're going to be looking at today, is sometimes we won't be able to use our one-to-one property. So then we need to know what to use next. And we've talked about this a little bit. Remember, we've said that logarithms and exponentials are inverses of one another. So if I raise a logarithm to a power of a base of b, and my logarithm also has a base of b, what happens? They reduce, yes, so what are we left with? X. Now what if it's the other way? If I have log base b of b to some power, what also happens? Are they still inverses? So are logarithms and exponentials still inverses? Do I still have the same base? So what does it equal? It just equals x. Are we okay with that? And the reason we like that property is because it allows us to undo things when our equation has logarithms or exponentials in it. Just like when we have x squared, we would take the square root of both sides, right? Or like when we have addition, we would subtract from both sides. This is the inverse, so that's what we're going to do to both sides in order to solve. Yes? No? Maybe? Questions so far? Okay. A couple people still writing. I'll wait just a second. Alright, so which one of those properties is probably going to be a little bit easier to use? The one-to-one, and that's the one that we want to use first. So when we're looking at these problems, okay, our first step is to isolate the log or exponential. And that'll look different depending on what the equation is. Our next step is to use the the 1-to-1 property. If possible. Remember, we said that sometimes it won't be possible. And then lastly, we use the inverse property. And the inverse property will always work. Okay? And then once you have it all solved, we need to check for extraneous solutions. What does extraneous mean? Yes, no, maybe. Use some of our English skills. What's the word extraneous mean? A lot. Or like extra. Yeah, extra hard. You have to do an extraneous workout. Agreed? So for us, basically, it means an extra solution. So which one of our types of equations, exponentials or logarithms, has restrictions on what we're able to plug in? A logarithm. What is that restriction? Like if we have log base b of x, what is the restriction on x?
X has to be greater than 0.
Agreed. So we're going to have to check our solutions and make sure that when we plug them back into our logarithm, that we end up with positive things on the inside of our logarithms. Are we all right with that? Questions so far? So let's look at some examples. So let's look at our exponential equation first. So here it tells us to solve the equation and approximate the result if necessary. So what did we say we want to do first when looking at an exponential equation?
1 to 1.
Yes. Before that, isolate. Well, are each of my exponentials by themselves? Yeah. Is there anything on the outside of either one of them? No. So they're already isolated. So then yes, we want to use our 1-to-1 if possible. So do we have the same base for both sides?
Yes.
Yes. So can we use our 1-to-1?
Yes.
Yeah. What do we end up with then?
Negative x squared equals negative 3x minus 4.
Agreed. So what type of equation is that? It's a quadratic. So what are we going to have to do in order to solve? We want to get it set equal to 0. So I would probably add our x squared over, because usually it's just helpful for the x squared one to be positive. And then how do we solve a quadratic? Which is a way to do what? Factor. We want to try and factor first. If we cannot factor, then what do we use? No, the AC method is factoring. So if you can't factor, then what do you use? Nope. The quadratic formula. Okay. Now, if we are still struggling with the factoring, we really need to make sure that we're coming in to get extra help on that. Because factoring is not going away. Ever. Okay? We're going to use factoring the rest of the year and all of the other topics that we do. You're going to use factoring in your future math classes, whether that be here or at college. So like you have to know how to factor. So make sure that if we're still struggling with that, we really need to get some tutoring one-on-one with that. Okay? So what does that factor to? X minus 4 times x plus 1. So what do we get as our answers? Agreed. Now, then our last step was to check for extraneous solutions. Will both of those work for me? equation do we have here? From the very beginning. Is it an exponential or a logarithmic? Exponential. Does our exponential have any restrictions on the domain or what we're allowed to plug in? No. So we can have negatives for our exponentials. That's all right. So for this one, both of these would be our answers. So we have two answers this time, which is fine. That just means both of those answers make that equation work. Questions so far? Alright, what about part B? What did we say our first step is? Isolate. Is my exponential isolated right now? No, what's going on? There's a 3. What's happening to the 3? Multiplied. So how do I undo a 3 that's being multiplied? Divide. So I get 2 to the x equals 14. Now, can I just divide by 2 and say that x equals 7? Yay, I'm done. Why not? I can't square root both sides either, because that does not undo a power of x. Agreed? So what's the issue? Where is our x, or where is our variable? In the exponent. So we can't just divide by 2, although that's a really common mistake, that people just want to divide the 2 out and get that x equals 7, but that does not make that equation true. Okay? The other one is that people see a 2 and they want to take the square root, but again, that's not undoing an exponent of x. What undoes an exponent of x? A logarithm. So we have 2 ways that we can do this. Okay? The first is, like I said, remember, using our inverse property. Exponentials and logarithms are inverses of one another. Agreed? Okay. So just like we're allowed to take the square root of both sides, or square both sides, we are allowed to take the logarithm of both sides. We all with me? Now, we want to be strategic about what base we pick. Okay? So if I have 2 to the x, what base might we want to pick in order for them to undo each other? So what base do I want to be on my logarithm? Why? Okay, so if I go back to my inverse property, right? What has to be true in order for these two things to undo each other? They have to have the same base. So in order for our logarithm to reduce with our 2 to the x, what does our logarithm have to have a base of? 2. So these undo each other, so we end up with x equals log base 2 of 14. Yes? Now, the other way that you could have done this, because this is a pretty straightforward exponential equation, you also could have just used your logarithmic form, right? So if we take 2 to the x equals 14 and convert to logarithmic form, we would have ended up with log base 2 of 14. Agreed? So this one is simple enough. There's not like extra x's or like weird things going on to where that we could do that. Now, there are some cases that the only way to solve it would be to take the log of both sides. So just make sure that you know how to do that. But if it's simple enough like this, I'm okay if you just rewrite it in logarithmic form. Okay? Now, what does it tell us that we need to do with our answer, though? Yeah, we need to take our result and round it to 3 decimal places. So what might we need to do? Use our handy dandy calculator. Just like Blue's Clues taught us. Now remember, if you have one of the scientific calculators, what am I going to have to type in?
I don't remember. I
Okay.
remember there's something for that. But I don't
Yes.
know what it is.
Because remember, your scientific calculators don't have a button that allows you to put in a different base. So what do we have to type in instead? Yes, no, maybe. It was in our logarithmic properties. What property allows us to convert it to a different base? So look back in our notes. It was like in the first one we went over.
Natural log?
Nope.
No. What?
What was the first property that we went over in our logarithmic property section? Nope. Before that. Change of base formula. So remember that if you have a scientific calculator, we're going to have to use our change of base formula and type in log of 14 divided by log of 2. Because there's not a special button on your calculator that allows you to put in log base 2 of 14. So what do we get if we type that in? Whichever way.
3.807.
And that'll be our answer. Questions on that? How do we feel about exponential so far? Okay.
The last one wasn't too bad.
Good. Alright, so let's look at another one. Alright, what's happening on this one? What's our base? E. Do I have a base of E on both sides this time? So, am I going to be able to use my one-to-one property?
No.
How do I know automatically? I know, but like, could I potentially rewrite them as the same base? Like, if I have a 2 and a 4, I could rewrite my 4 as 2 squared, right? Why not? Because it's irrational. So remember, E is an irrational number. So if you only have an E on one side, you are not going to be able to use our one-to-one property. But that's okay. So what is our first step then? Subtract the 5 because we need to isolate our exponent. So we get E to the x equals 55. So then what do we want to do? If we can't use our one-to-one property, which property do we want to use? The inverse. So what do we want to do? Take the natural log. Why did we pick the natural log?
Because it's E.
Because it's E. So remember, our natural log is the logarithm that has a base of E. So now, what happens with our natural log and our E to the x? They reduce, and we just have equals the natural log of 55. And again, they ask us to round. You have a natural log button on your calculator. So what do we get that answer is? 4.007. Same spot. Are we all able to get that answer with whatever calculator we're using? Because you will have some on your homework where you need to round for your decimals. Alright, so I want you to try the next one on our own.
That's it. Wait. Just go here. Just go for chemistry.
But you don't want there to be another parenthesis.
Huh?
do we say our first step is? When I'm dealing with exponentials. Isolate. So what are we trying to isolate? The 3 to the stuff, yeah? So we would add 4, divide by 2, so we get what? 7.5. So then, in order to undo our exponent, we need to take the log of both sides, specifically the log of 3 this time. My log base 3 and my 3 undo each other, so we have 2t minus 5. Now, be careful, because I saw on a couple people's, they just put 2t minus 5 equals 7.5. We cannot do that, because when we took the log of both sides, okay, the only way that works is if I take log base 3 of 3 to the stuff, and that's what undoes each other. So I am left with 2t minus 5, but because I had to take the log of both sides, I still have log base 3 of 7.5, okay? Also, be careful. You are going to end up with a decimal approximation, but don't round your answers too early. Because some people would go ahead and type this into your calculator and approximate this. But if I do that and then do other things to that rounded answer, you're basically making your rounding error even bigger, okay? So leave your answer exact for as long as possible. So then I would have to add 5 and divide everything by 2. And then we get to plug all of that into our calculator to get a decimal approximation. So what do we get?
3.417.
Okay, now also be careful, because once I've taken the logarithm, I can't add or divide or do anything else to the number that's inside of the logarithm. So I can't add my 5 to my 7.5, because I added 5 after I had taken the logarithm. So that has to stay on the outside. So you need to make sure that you end the parentheses after the 7.5 when you're plugging it in your calculator. We all with me? Yes.
I noticed on this calculator, once you've gotten the answer for the log, if you don't start a new line and then you just put plus 5.
Yeah, you
then
can do
keeps
it
the
that
number
way.
the same.
Yes, because it's not rounding. That's different than if I tried to type this in and then rounded to whatever this was, like 6.249 or something like that, and then did those things. Your calculator is basically storing what you did on the previous line,
Right.
so it's still using the entire decimal.
Yeah, that's what I'm saying.
Other questions? Concern? Come. Okay. So let's look at some logarithmic functions now. Your steps are still going to be the same. Okay, so what's our first step? Isolate. Just this time, instead of isolating the exponent, we're isolating the logarithm. So on our first one, we have the natural log of x. Is our logarithm by itself? Yes. Okay. So what do I want to do to undo the logarithm? I'm going to use an exponent, right? Agreed? Okay. So this is what we call exponentiating. Basically, we're going to put both of our sides and make them powers. So I would want to use the same base that my logarithm has, which in this case we have a natural log, so it's going to be an e. And we're going to put both of those things into the power. So notice that I'm not raising it to a power of e, like e is not in my exponent. I'm making the stuff I already have the exponents, and that's called exponentiating. Y'all with me? Okay. Now, using our inverse property, what does e to the natural log of x equal? Just x. And then we have e squared. And that's our answer. And then if we wanted to approximate it, you have an e button on your calculator. And you would just round to 3 decimals. what do we get?
7.389.
What is it? 7.
7.389.
So make sure all of us can find our E buttons on our calculator. Alright, what about our next one? What do we want to do? Yeah, they already have the same base, so what property are we allowed to use first? The one-to-one property. Remember, that's always our first goal. If we can use our one-to-one property, it makes our lives a whole lot easier. So we would just combine our x's. So we subtract x, get 4x minus 1 equals 7. Add 1, divide by 4, and we get that x equals 2. Yay! We like the ones that we can use our one-to-one property on. Questions on that one? Alright. So, I want you to try this one on your own. Alrighty, it looks like most of us have finished. So again, remind me, what is our first step? Isolate our what? The logarithm. So we get that the natural log of x equals negative 1/2. So then, again, we have a natural log. So remember, our natural log has a base of e. So when we exponentiate, we want to use a base of e. And we get that x equals e to the negative 1/2. Now, most of us probably just plugged it in straight from here into our calculator, which is fine. What do we get?
607.
607. Now, how would we have rewritten that if I wanted the exact answer? What does a negative exponent do? Puts it in a fraction. What's a 1/2 do? Makes it a square root. So this would be the same thing as 1 over the square root of e. But this would just be if they asked us for the exact answer. If they just ask you to round, then your 0.607 would be your answer.
Is that going to be in the test?
What?
Exact.
I mean, you need to know how to simplify things that have negative and fractional exponents. Because we went over that when we did our one-to-one properties. Remember, we had some that we had to rewrite as negative exponents in order to make the fractions. That's more likely where you would see it come up, not one like this, but you still need to know those properties. All right, we have one last problem to look at. So what's different about this one? There is an x minus 1. What else? The logs are on the same side. We use the plural of logs, which means there are how many? We have 2 logarithms, yes? So if we have 2 logarithms, what have we mostly done in the past?
Combine them?
Yes, but for our equations, what property did we use? When we had 2 logarithms. The one-to-one property, okay? But because they're on the same side this time, it's a little bit different. Notice that even if I moved one of my other logarithms over, we would have 2 minus a log. Agreed? So we have something besides just one logarithm, so we can't use our one-to-one property. Are we all with me?
Yeah.
So our goal, remember, first is to isolate the logarithm. Well, do I just have one logarithm right now? No, and that causes issues. So, like Evan said, we do want to combine them to be one logarithm. How do we do that?
With the product property?
Yeah, with our product property. So remember that our addition between 2 logarithms can become multiplication inside of 1 logarithm. So then I'm going to go ahead and simplify the stuff that's inside of my logarithm. So we would just distribute that 5x. We get 5x squared minus 5x. So then what do we want to do? My 5x squared minus 5x is inside of my logarithm. So how do we get rid of the logarithm? The exponential. So specifically, an exponential with a base of what this time? 10. Because notice that our logarithm has an understood base of 10. Agreed? So I would have 10 to the log of 5x squared minus 5x. And then what do we have on the right side? 10 to the second, which will be 100. But be careful on that right side, because a lot of people just want to write 2. Okay, but remember, what I do to one side, I have to do the other side. So if I make this a power of 10, I have to make that a power of 10 as well. So we end up with 5x squared minus 5x equals 100. So what type of equation are we going to have? It's a quadratic. Now, what might be the first thing that we do to make our lives a little bit easier? Well, we will be able to factor here before that.
Oh, yeah.
By what? Yeah, so if we divide everything by 5, it makes it not as big of numbers, which is a little bit easier to deal with when we're trying to factor it. So now, what two numbers multiply together to give us negative 20 that add together to give us negative 1? 5 and 4, one of them needs to be negative. Negative 5 and positive 4. So what are my two answers? 5 and negative 4. But what do we need to do?
Check for extraneous solution.
Agreed. So notice that when we plug in our 5, we would have log of 25 plus log of 4 equals 2. No issues with that one. Okay, but when we plug in our negative 4, notice that we get log of negative 20 plus log of negative 5 equals 2. Does that have issues? Yeah, because we have negatives there, which means that negative 4 would be an extraneous solution. So 5 will be our only answer that works. Are we all okay with our steps? Where did I get the 10 from? So remember that just like our natural log has an understood base of e, remember that if my logarithm doesn't have a base, it's an understood base of 10. Does that make sense?